Let us now discuss the operations that we can do on the linked list. I am assuming a singly linked list here, but the operations work well for every type of linked list. So first of all, let's define the building block of the linked list. Let's call it a node here. Now this node has a structure which will have some information. It can be some integers, some strings, whatever information you want to store per node, and one pointer which will point to the next element in the linked list. This is a very important pointer because this is what will tell where to go next from the current unit. So let us suppose we want to build a linked list. First of all, we need to keep track of two things. One is where the linked list starts and one is where the linked list ends. We typically call this the head pointer and the tail pointer. Initially, suppose I have one element in my linked list which has some integer information, say 7. At this point, because this is the starting and the end of my linked list, both my head pointer and my tail pointer point to this element. Now suppose I want to add another element to this list. I allocate some memory and I provide some information, which is say the integer 5. Now I have this node structure here. What I want to do is I want to add it to the linked list. So what I'm going to do is I will go to the first element, take the next pointer of this first element and point it to the new element that I've just created. Now my linked list has become of size 2. While my head pointer remains to be the first element, my tail pointer needs to shift to the new element because now this element with the information 5 is my new end of the linked list. So this should go away and my tail pointer should now point at the second element. Similarly, if I want to add a new element, which will be the third element, I can allocate some memory, add the information required, and then I can take the next pointer of the second element, point it to the third element, and change my tail pointer to point to the last element. Please notice that every time we're adding a new element, we just need to go to the element which is pointed at by the tail pointer and point its next pointer to the new element. For example, when we add a fourth element, I will look at where my current tail pointer is right now. My tail pointer right now points to this element, which is the last element in my linked list. So I just need to consider the next pointer of this element and point it to the new element. That will be all. What if I want to do something like insert in the middle? Now in arrays, something like this is not possible because arrays are contiguous in the memory. Since these are not contiguous in the memory, I can insert in the middle. Suppose I want to insert this new element which contains the information 8, suppose, and I want it to be on the third position. So I basically want it here between 5 and 2. So what I can do is I can take the next pointer of this node, point it to my new element, and take the next pointer of my new element and point it to 2, which will result in something like 7 pointing to 5, pointing to 8, pointing to 2, which is how I will build a new modified linked list where I have inserted this element in the middle. For deleting, I can use the same concept. Suppose in this linked list, I want to delete the element 5. So what I can do is I have a next pointer here. I can take this next pointer and point it directly to 8. When I do this, I have no way of reaching this element which is 5. From 7 I will go directly to 8 and from 8 I will go to 2. So my linked list will become something like 7 pointing to 8 pointing to 2. How exactly these operations are implemented, you can look through our experiment and you will understand with the demos and the practices. Traversal of linked lists depends on whether it is a singly linked list or a doubly linked list. If it's a singly linked list, then you can only traverse one way, which is forward. If this is my list, I can go from 7 to 8, 8 to 2, but I cannot go from 2 to 8 and backward. If it's a doubly linked list, then I will have connections like these, and I can traverse both ways. Basically, if you are at a singly linked list, traversal is linear, and if I want to reach the nth element, I cannot directly jump to the nth element. I'll have to traverse all elements from the first till the nth to go there.